Okay. Welcome back. Lynn, your presence. Lynn, Mzungu, Geoffrey. Okay, welcome. We continue for today's lesson, acid-base titration. Acid-base titration. So this is a type of neutralization reaction, also referred to as acid-base titration. So as the name suggests, you must have an acid and also a base for such a reaction. And normally the acid should be a standard solution and the base is a substance to be standardized. So from that page you can see a setup for acid-base titration. So you can be able to see we have the retort stand and a clamp that holds the burette. We have a conical flask. We also have the white tile, and we are saying that the burette should contain the acid and the conical flask should contain the base. So for every titration setup, this is the way you should be able to go. So we're saying that titration is a method of analysis that will allow you to determine the precise endpoint of a reaction and therefore the precise quantity of reactant in the titration flask. So the endpoint is that point at which the acid completely neutralizes the base. Notice that we have another term known as the equivalence point, which is closer to the endpoint, and the two definitions actually explains that point at which the reaction is complete. We have a burette. The burette should also be calibrated, and it is used to deliver the second reactant to the flask. So as I said before, that is a standard solution, which is the acid. We also have an indicator for titration, or you can use a pH meter to detect the endpoint of the reaction. So to begin with, start by preparing your burette, or generally the apparatus that you are using, the burette, the conical flask, the pipette in which you are transferring the aliquot portions of the base. Ensure that you rinse with a soap, that's a liquid soap. Then you also rinse with tap water, and you rinse with the reagent that you're using. If it is a base, if it is an acid, then you rinse with the titrant. You should also check for air bubbles and leaks when you're using the burette before proceeding with the titration. Be sure the tip of the burette is filled. Never dispense the liquid that is below the last calibration. So moving on to the next slide, just a minute. Moving on to the next slide, this is how to read. Remember to read the lower meniscus. So you take an initial volume reading and record it just the way we've been doing. And before beginning a titration, you should always calculate the expected end point. So as you know that for precise measurements, then you should carry on three trials. Ensure that you carry on 3 trials. Then moving on to the next slide, slide number 5. Prepare the solution to be analyzed by placing it in a clean Erlenmeyer flask or a beaker. So for this case, the Erlenmeyer flask is another name for conical flask. So if your sample is a solid, in case you want to analyze a solid sample by titration, then you should be able to dissolve completely using distilled water and make sure such a dissolution is complete. Then you add an indicator depending on the type of the acid and the base that you're using. The indicator for a strong acid and a stronger base is different from the indicator that you're using for a strong base and maybe a weak acid. So you choose the indicator that you are using wisely. So to the next slide, that is how the titration is being carried. Use the burette to deliver a stream of titrant to within a couple of milliliters of your expected endpoint. You will be able to see the indicator change color when the titrant hits the solution in the flask, but the color change disappears upon stirring or shaking or swirling. Then as you approach the endpoint, titrate very slowly and watch the color of your flask carefully. Use a wash bottle to rinse the sides of the flask and the tip of the burette to be sure all titrant is mixed in the flask. Make sure you know what the endpoint should look like. As I said, depending on the acid, on the indicator that you're using, then you should be able to know what the color of the endpoint are you expecting. So for phenolphthalein indicator, the endpoint is the first permanent pale pink. You know that in acid, the color, the pink color for the indicator turns colorless, and in basic the color is pink. So the pale pink fades in 10 to 20 minutes of your titration. So to the next slide, if you think you might have reached the endpoint, then you can now record the volume reading and add another partial drop. So sometimes it is easier to tell when you have gone past the endpoint. So if the flask looks like what you're seeing from that diagram, then you have gone too far. Whenever there is that intense color, then you must have gone that too far. So for acid-base indicators, an acid is a weak acid or a weak base. The undissociated form of the indicator is a different color than the original form of the indicator. An indicator does not change color from pure acid to pure alkaline at specific hydrogen ion concentration, but rather color change occurs over a range of hydrogen ion concentrations. This range is termed the color change interval. It is expressed as a pH range. So to this last slide, we also have litmus. Remember, we have litmus paper, we have litmus solution, and in this case a litmus is a weak acid. It has a seriously complicated molecule which we simplify to H lit. So we are just calling it a seriously complicated because it is a complex molecule. So for simplicity, we use that abbreviation where H is the proton, that's the hydrogen ion, which can be given away to something else. So the LIT is the rest of the weak acid molecule. There will be an equilibrium established when this acid dissolves in water. So taking the simplified version of this equilibrium equation, where that complex molecule dissociates into hydrogen ions and the rest part of the base. So the unionized litmus is red, whereas the ion is blue. So the unionized takes that form, the HLIT, and the ion takes that form, LIT negative, and that is the basic part of the dissociated complex ion. So for a litmus indicator in acidic medium, the solution turns blue, but in basic solution, then the litmus turns the red litmus turns blue. So that clearly tells us, or you can be able to use to locate the endpoint for the titration that you are carrying on. So by now, I hope all of us have understood how to carry on the practical. We have said that you must set the apparatus according to the diagram that I had given you. You must also ensure that you have all the reagents, that is the standard solution and the solution of unknown concentration, which you want to determine its concentration. And also you ensure that you have the indicator for you to locate the endpoint. So once you've located the endpoint, you've calculated the average volume, then you can go ahead and determine the concentration of the substance you are interested on. Otherwise, thanks. That is our discussion. Any question? Mzungu? Geoffrey? Response from Obara?
No question.
No question. Thank you and welcome. Next time we will proceed.